Hey, this is Brock Lemires, and in this video I'm going to go over lab number 6 on looping structures in C and building the Ohm's Law calculator. All right, so the objective of this lab is for you to just to gain experience using loops, and in this one you'll probably do a do-while loop, but you're basically going to create a program that will continuously perform a calculation called Ohm's Law, and you'll do it as long as the user wants to continue. And so you'll give the user an option to enter Q to quit if they ever want to quit. Otherwise, they hit any key and they can return to the top of the loop and enter in more values for you to calculate. Okay. Deliverables are going to be screenshot of your result for a set of different test conditions, in addition to showing that the user can hit Q and leave, and then your source code. All right. So a little preliminaries. Ohm's Law. Ohm's law is a powerful expression that relates the electrical current to the electrical voltage across a component called a resistor. A resistor is an electrical component that really does resist the flow of electrons. So it doesn't slow them down. It just limits how many electrons can flow through the material at any given time. And it just has to do with the material makeup of it. It just doesn't have as many electrons to allow to pass through or allow to get displaced from their atoms. Okay. These are examples of what resistors look like. You might recognize this from some of your electronics classes. This little fella right here is the size of the resistor that you use in your breadboards. Okay, a resistor has a unit of ohms, and it has a resistance value that describes how much it resists the flow of current through it for a given voltage. Ohm's law is very simple. It's simply V is equal to IR, and it's the voltage across the resistor, and you give it in any two of the three parameters. Okay, so if you had a given resistor and you put current through it, you'd get a voltage, or if you had a given voltage across the resistor, you could calculate the current. Okay, and that's all there is really to it. So you can kind of read through here and get a feel for the ohms and coulombs and stuff like that. Electrical power is interesting because the definition of electrical power is simply P is equal to IV, where P is power in watts, I is current in amps, V is voltage in volts. And you notice that these two equations can actually be plugged into each other by substituting V into here. And you can actually get a new expression for the power across a resistor, which is simply P is equal to I squared R. Okay. Now, if you try to do that in C right now, we don't have a square root. We don't have a power function yet. But you can still do it. You can just say P is equal to I times R. Okay. Notice that these are just simple algebraic equations, right? So you can rearrange them and find whatever variable you want for given the other two. Engineers made this thing called an Ohm's law wheel, which basically does it lays out all the calculations for you graphically. So for example, if you wanted to find voltage across a resistor, you could have three equations where if you were given power and current, you can find the voltage. If you were given power and resistance, you can find the voltage. If you were given current and resistance, you could find the voltage. So what you're going to do in this one is basically you are going to calculate resistance, or excuse me, voltage, or you're going to calculate one of these things. Okay, so here's what you're going to do. You're basically going to start a program and you're going to enter, welcome to the Ohm's Law calculator, enter R and I, get V and P. Okay, so you're going to take in the resistance, take in the current, and you're going to calculate the V and you're going to calculate the P. Notice that V is equal to IR. So if they give you R and I, you simply multiply them together, get V. If you want to find power, you just do I times R. So the equations are all above you. Okay, however, the big thing about this is that you are going to create a system that prompts the user for ohms and amps, which is resistance and current, and then you calculate those two values, echo them back, and then ask them if they want to continue. So this is what your program is going to look like when it runs, okay, just to jump to the end. So I have mine right here, Ohm's Law. Welcome to the Ohm's Law calculator. Let me move this over so you can see it. And I enter resistance. whatever. I enter amps. It'll say, given what you just gave me with these significant digits, the voltage is this, power is that. Do you want to do another calculation? Press any key to continue. So I enter a character and I'm back at the beginning, 40 and 4. And then I want to continue, hit any key and 2 and 2, 1000, whatever. And you keep going and going and going until if you want to quit, you hit Q and you're out of the lab. You're out of your program. So this is getting more realistic in terms of a usable program where you fire it up, you do a bunch of calculations, and you have the option to actually get out of the program. So that's what your lab's going to look like when you're all said and done. So you're going to have to set up a looping structure. I'd do a while loop because you know you're going to prompt this at least once, and you're basically going to stay in there until the user enters the character queue. All right, that is it, and good luck.